Good morning, students. Today we are going to start a new article of application of derivative, which is very important in the field of mathematics. And the name of this topic, which is already written there, tangent and normal. The word tangent is not new to you. You know the concept of the tangent in standard 10. As you know, the tangent is drawn to a circle. Then what is the definition of a tangent? You know it is a straight line which touches the circle exactly at one point. And where the tangent is drawn to the circle, that is called the point of contact. So that idea is already with you. So you see, the syllabus of the 10th, 11th and 12th is designed in such a way that the 10th having connected with the 11th, 11th is also connected with the 12th. Let us see how this syllabus is designed. You know tangent in the class 10, and you thought tangent is only drawn in case of circle. But when you come to the class 11, then one chapter was there, equation of straight line. So though the tangent is a line, so there it is introduced the equation of a straight line. And then also you know the concept of the function. So what does mean by the function? Y is equal to f of x. So y is equal to f of x is a function where the graph is any type of curve. If the graph is any type of curve, at any point on the curve, we can draw a unique line which touches the curve exactly at one point. That is also tangent. So the mindset is changed from 10 through 11 that tangent is not limited in case of circle. So tangent can be drawn for any type of function having some curve. And again, what is the tangent of a straight line? The tangent of the straight line is the line itself. Then in the 12th class, we are going to read the equation of the tangent and normal. Of course, the word normal is new to you. That we will discuss today, both the tangent and normal. But my point is to say how the syllabus of the 10th, 11th and 12th are interconnected. So once again I am reminding, because in the class 12 we are going to find the equation of the tangent and normal. As you know, tangent is a straight line, means indirectly we are finding the equation of a line. And to find the equation of the line, you know so many cases. Once again I am reminding what you know in the class 11 to find the equation of a straight line. The first concept was coming of the slope. So what does mean by the slope? If this is your coordinate axis, say x axis, it is y axis, any line is drawn, let this line makes angle theta with the positive x axis. If the angle of inclination of the line is theta, then we are telling the slope denoted by m is equal to tan theta. So slope of a line we can able to get, m is equal to tan theta. Then the second concept, just remember how to get the slope of a line if the line is passes through 2 points, say x1 and y1 and x2, y2. Just recall what is the answer or what is the formula to get the slope. I am reminding to you. In this case, the slope m is equal to y2 minus y1 divided by x2 minus x1. That means if the line is passes through 2 points x1 y1 and x2 y2, the slope will be y2 minus y1 divided by x2 minus x1. Then you recall another concept. The equation of the straight line, already you know in the standard 10, the standard form of the equation of the straight line, ax plus by plus c is equal to 0. If the equation of any straight line is given to you in the form of ax plus by plus c is equal to 0, you recall the third concept what I am telling. Then if the line equation is ax plus by plus c is equal to 0, then the slope is minus a by b. That means we know three types how we can get the slope. If the angle is available by the straight line, and the second one, if the line is passes through 2 points. The third point, if the equation of the line is available to us. Then let us think what you know more about the slope. Recall, if the two lines are parallel, then the slope are equal. If suppose the two lines are there, L1 and L2, having slope M1 and M2, then if these two lines are parallel, then M1 must be equal to M2. If the two lines are perpendicular to each other, having slope M1 and M2, then the product of the slope is minus 1. That is M1 into M2 is equal to minus 1. That I am showing in this form. I am showing to you how it is coming. M1 into M2 is equal to minus 1. And the third concept also you know how to get the angle between the two intersecting lines. Let the line L1 and L2 intersect at a point P say. So once again I am telling, let the line L1 and the line L2 intersect at the point P. Let the angle between them is theta. Then how we are getting the angle between the two lines? That is equal to tan theta is equal to M2 minus M1 divided by 1 plus M1 into M2 modulus. We are taking modulus. We are taking modulus because if we open the modulus, then the plus and minus will come. If the plus and minus will come, because you know angle between the two lines may be this angle or may be this angle, and both the angles are supplemented to each other. So tan in the first quadrant or tan in the second quadrant. Tan in the first quadrant will be positive and second quadrant will be negative. That means if this angle is coming positive, so we will think out the acute angle. If it is negative, we will think out it is obtuse angle. So that concept also you know. Once again you remind, what is the slope of x-axis? Because x-axis is a line itself. So the slope of the x-axis is 0. Why? Because x-axis makes angle 0 degree with itself. So tan of 0 is coming 0. So the slope of the x-axis is 0. Similarly, tell me what is the slope of the y-axis? Because y-axis makes angle 90 degree with x-axis. Because we are telling the angle of inclination with the positive x-axis. If the y-axis is making angle 90 degree with x-axis, so tan 90. So tan 90 is equal to not defined. But here, instead of writing non-defined, we will write 1 by 0. Because if we take non-defined, then you cannot do any algebra, neither in addition, subtraction, multiplication, division. Instead of infinite or non-defined, if we take 1 by 0, at least with the cross multiplication, we will get the answer, because line those are parallel to y-axis, they must have some equation. And in this cases, if you use the slope is equal to non-defined, then your calculation will be stopped there. So instead of taking non-defined, it is my suggestion you take 1 by 0. So I already remembered you that what is slope, how to get slope in the different ways, and what is the relation of the slopes if the two lines are parallel to each other, if the two lines are perpendicular to each other, and how to get the angle between the two lines if their slopes are given to us, and the slope of x-axis and the slope of y-axis, what we know in class 11. And second thing that I want to say you, about the tangent that what I am going to tell. So for any function y is equal to f of x, let y is equal to f of x is a function. Let the graph is looking like this. Let the graph is looking like this. So here I can draw one tangent. Here I can draw one tangent. Here I can draw one tangent. So tangent can be drawn at any points of the domain of the function. So this is the concept of the tangent from standard 10 to standard 12. Let us discuss the more about the tangent. So my aim is to say that from class 11 to class 12, when the derivative was introduced in the class 11, you know the derivative is nothing, that is the slope of the tangent. So that is also true, and that we are going to discuss here. Let you take any function y is equal to f of x. Let's draw the graph of this function. Let us see the graph of the function is looking like this. And I am choosing one point, suppose P, where the tangent is drawn. Now, if the name of the function is f of x, then if you will find f dash x or dy by dx at the point P, that is nothing, that is slope of the tangent. So once again I am telling, the slope of the tangent is the derivative of the function. If you will not choose the point, then that will be the slope of the any tangent at any point. So though the tangent is required to be drawn at a particular point, so we have to choose where we are going to find the slope of the tangent. So derivative of the function at this particular point, that is your aim, that is equal to tan theta, that is also equal to y2 minus y1 divided by x2 minus x1, that is also equal to minus a by b if the equation of the tangent is given to us or equation of the straight line is given to us. So once again you remind what you know in the previous chapter, that is continuity and differentiability. In the continuity and differentiability, just you recall, one by one you recall. So you know what is continuity, what is differentiability, and then you know how to get the derivative of the different functions. So you know the derivative of the implicit function, derivative of the explicit function, recall one by one you recall, and the derivative of the parametric function, which is already suggested there. Suppose x is equal to function of t and y is equal to function of t, then we are finding dx by dt and dy by dt, then we are finding dy by dx, that is slope of the tangent, is equal to dy by dt divided by dx by dt. That also you know. Again, you also know how to get the derivative of a function by using logarithm and exponential. exponential and logarithm using, you can find the derivative of function. Then some special type of functions are there. There are also derivatives also we know. So we will assume that you know how to find the derivative of a function in the different methods and the different types of function. That is the basic knowledge required to come to this chapter in comparison to the previous chapter. Now I want to give you the believing, how, whether you are a believer or not. Then in the 11th class you know the slope of the tangent in the different way, and the 12th class and you will think the sir is telling the slope is nothing, that is the derivative. That I want to show you one or two examples. See, I am giving one example. See, suppose the line 2x minus y plus 6 is equal to 0. It is a line, and the tangent of the line is the line itself. So the slope of the tangent is the slope of the line itself, and the slope of the line you know minus a by b. So what is a? Now a is the coefficient of x, that is equal to minus 2 by the coefficient of y minus 1, that is coming to the slope of the tangent or the slope of the line is coming 2. So let us verify this slope is equal to 2 by using derivative. So let us find the derivative of this function. What type of function it is? X and y is mixing form. So that is the implicit function. So the implicit function we are going to find the derivative. See. So differentiate with respect to x. So 2x derivative is coming to minus is there, derivative of y is equal to dy by dx, constant derivative is 0. So dy by dx is equal to 2. So dy by dx, the point is not there, direct the constant is coming. So here a b is equal to 2. Already in the 11th class you know the slope by using this formula minus a by b, the slope is 2. The same questions I have taken and only I applied the derivative. That's why the name of the chapter is application of the derivative. And you found dy by dx is equal to 2. You will be astonished that sir, why the dy by dx at any point we are not getting? Because I already told the slope will be found in the different points. But before that also I told it is a straight line, and in the straight line the tangent is the line itself. So the point is not required. At every point on the line the slope will be same. So here the point is not required. So directly the slope is coming to. So it is one of the verification, and you try to believe it. Yes, what the derivative we are going to find, that is the really the slope of the tangent. In graphical method I am showing another question to you. See, in the 10th class also you know the y is equal to x, and you are very much habituated to draw the graph of this function. The graph of the function is like this. It is symmetrical to x-axis, so the first quadrant and the third quadrant. Because whatever value of x you will put, y will come this one. So obviously this will be 45 degree. Because if you take x is equal to 1, then y will be 1. So it is an isosceles triangle. Isosceles right angle triangle. Isosceles right angle triangle means this angle will be 45 degree. So the slope here, by using the first concept of the slope, that is m is equal to tan theta. So m will be tan 45 degree. So tan 45 degree, what is the value? 1. Yes, the m is equal to 1. The slope is equal to 1. I have drawn one graph of the function. It is a familiar function, and by using this concept of the tan theta, we got the slope is equal to m is equal to 1. So let us apply the derivative here, whether it is coming or not. So it is very easy function, y is equal to x. Now again differentiate with respect to x. Derivative of y, dy by dx, derivative of x, 1. So dy by dx is 1. Already you got m is equal to 1 by using the concept of the tan theta, and same thing you applied in the derivative. You are getting dy by dx is equal to 1. So my dear students, by seeing these two examples, it is very clear that the derivative of any function is nothing that is the slope of the tangent. So this is the by using minus a by b, which is equal to slope, and here we got by using m is equal to tan theta. Now we will go to the concept, the tangent and normal. So let us see one function. Say any function you take, y is equal to f of x. Let us draw the graph and see I am finding one tangent at the point P. Then what is normal? Now normal is also a line perpendicular to the tangent through the point of contact. So what is normal? So we should write the definition of the normal. So let us write the definition of the normal. Write down. Let us write down the definition of the normal. It is a line perpendicular to the tangent through the point of contact. So here the figure is very clear. So in this figure, this is the tangent, no doubt it is the tangent, and obviously it is 90 degrees suppose, so it will be the normal. So this is the normal, this is the tangent, and the point P is the point of contact. So if the tangent and normal are perpendicular to each other, and we know how to get the slope of the tangent by using the derivative. If the slope of the tangent is getting by the derivative, so the slope of the normal is perpendicular to it. So use the concept that if the two lines are perpendicular to each other, the product of the slope is minus 1. So if I will tell like this, suppose the function is y is equal to f of x. So m is the slope of the tangent. So slope of the tangent is equal to dy by dx at a particular point P. So similarly I can write slope of the normal. Slope of the normal. That is m also equal to minus 1 by dy by dx at a particular point P. Or if you will take it is m1 and if it is suppose m2, so m2 will be equal to minus 1 by m1, because the product of m1 into m2 is equal to minus 1. So slope of the concept and the slope of the normal already discussed. It is nothing but the finding the derivative of the function at the indicated point. Students, for your easy remembering, I divided this concept into 3 parts. I have divided into 3 parts, the type 1, type 2 and type 3. The 3 types of questions we will go to discuss. Let us see the type 1 what I am discussing. In type 1 we will take how to get the slope and the tangent of different curves and the equation of the slope and tangent. The slope and the tangent of different functions and the equation of the tangent and normal. So we will discuss one question. Let us see the question number 1. Write down. Write down the question number 1. Find the slope of tangent and normal to the curve or to the function y is equal to x cube minus 2x at x is equal to 2 say. So let us read the question once again. It is only one bar question will be there in the board examination. Find the slope of the tangent and normal of the function y is equal to x square minus 2x at x equal to 2. If it is asked both tangent and normal, then it may be 2 marks. So the function is given. So let us see how to do it. Very easy. Y is equal to x square minus 2x. So simply find out the derivative. So dy by dx is equal to derivative of x square 2x minus 2. And the point is given at x is equal to 2 only. The value of x is given here. So your slope m is equal to slope of the tangent dy by dx at x is equal to 2 I will write. So put the value of 2. Put the value of x as 2. So 2 into 2 minus 2. That is 4 minus 2. That is equal to 2. So m is equal to 2 means the slope of the tangent is 2. So slope of the normal. So obviously it is minus 1 by 2. So therefore I can write here, slope of tangent is 2 and a normal is minus 1 by 2. So this is the answer. So here you can get 2 marks. Very simple. Only to find out the derivative and the point is given to us. So the slope of the tangent and a normal is gone. Let us discuss another question. I am taking another question. Just you write down. Write down the question. Question number 2. The similar type of question, that is the slope of the tangent and normal, and only I am changing the equation of the function x is equal to 1 minus a sin theta and y is equal to b cos cube theta at theta is equal to pi by 2. You take cos square theta. So once again you see the question. Once again I am telling, try to understand what I am going to tell. Once again we are going to find the slope of the tangent and normal where x is equal to given 1 minus a sin theta and y is equal to given, I am writing once again here, y is equal to b cos square theta at theta is equal to pi by 2. What type of function it is? Yes, it is a parametric function where the parameter is theta here. So you know how to get the derivative of the parametric function. So let us find out the solution. Write down. Now for this case, find the derivative of x with respect to theta and find dx by d theta. Derivative of 1 is 0 minus a cos theta. Make it equation 1. So dx by d theta is equal to minus a cos theta. Similarly, derivative of y with respect to theta, dy by d theta is equal to b is the constant term, cos square theta, 2 cos theta, and by using the chain rule, the derivative of cos theta is coming minus sin theta. So it is minus 2b sin theta into cos theta. So dx by d theta is known, minus a cos theta, dy by d theta is given, minus 2b sin theta into cos theta. So now derivative dy by dx is equal to dy by d theta divided by dx by d theta. So put the values, dy by theta, what is given to us? Now minus 2b sin theta into cos theta divided by minus a cos theta. If you will take it as equation 2, it will be better. So equation 2 by equation 1, so minus minus cancelled, and a cos theta is also cancelled. So what is coming? Now 2b by a into sin theta. What is this? This is the slope of the tangent. The slope of the tangent, but the point is given, theta is equal to pi by 2. So put the value of theta is equal to pi by 2. So without writing this one, now write down m is equal to dy by dx at theta is equal to pi by 2. So putting the value of pi by 2, sin pi by 2 is coming 1. So 2b by a into 1. So that is equal to 2b by a. So the slope of the tangent, I am rubbing this part, see the slope of the tangent, already you got 2b by a. So now slope of the normal, slope of the normal, that is also a is equal to minus a by 2b. Let us discuss one question which is from the example of your textbook. Let's see the question number 3. The question number 3, write down the question. Find the equation of tangent and normal to x to the power 2 by 3 plus y to the power 2 by 3 is equal to 2 at point 1, 1. So this is the example of your textbook. The question is find the equation of the tangent and normal. That means equation of a straight line. So we are going to find once again the slope of the tangent, means once again the derivative. So let us try. Let us try how to get it. It is also very, very easy. Look at here. First, we are going to find the slope of the tangent. So the curve is given x to the power 2 by 3 plus y to the power 2 by 3 is equal to 2. It is an implicit function. Differentiate with respect to x. So x derivative 2 by 3 into x to the power 2 by 3 minus 1 plus 2 by 3 y to the power 2 by 3 minus 1 into dy by dx is equal to 0. So we can cancel 2 by 3 as the right hand side is 0. So let us find dy by dx. So dy by dx will be equal to minus x to the power minus 1 by 3 divided by say y to the power minus 1 by 3. Or in shortcut I can write the dy by dx is equal to minus y to the power 1 by 3 divided by x to the power 1 by 3. So the slope m, that is dy by dx, and the suggested point is minus 1, 1. So the suggested point is 1, 1. Putting the values of x is equal to 1, y is equal to 1, we are getting m is equal to minus 1. That is the slope of the tangent. If the slope of the tangent if the slope of the tangent is minus 1, so the slope of the normal will be plus 1. So the slope of the normal so obviously 1. So slope of the tangent is minus 1 and the slope of the normal is 1. Now equation of the tangent that is passing through the point 1, 1 with the slope minus 1. You just recall how to find the equation of a line using 1 point form. So 1 point form, y minus y1 m whole into x minus x1. So here x1 is the 1 and y1 is 1 and the slope is given minus 1. Putting the values, say y minus 1, slope is minus 1, x minus 1. So equation of the normal, same, y minus y1 m whole into x minus x1, that is equal to y. Again the y1 value is 1 and the slope is here 1 and x minus 1. So it is coming, say y minus 1 x whole into minus 1, that is coming, say x minus 1 and that minus 1 and minus 1 is cancel, is equal to 0. That is x minus y is equal to 0. This is the equation of the normal. So students, we have already discussed how to get the slope of the tangent and a normal in the different functions, and also discussed how to find the equation of the tangent and a normal at indicated point of the different functions. And the students, those are preparing for the entrance in the class 11, you know about the circle. The equation of the circle when the center at origin, just you recall back. Those are particularly preparing for the entrance, I am giving the tips to them. So the equation of the circle, you know, x square plus y square is equal to r square if the center at origin. If you want to find out the equation of the tangent at the particular point x1, y1, then the equation of the tangent becomes x into x1 plus y into y1 is equal to r square. Similarly, the different formula you recalled in class 11 in your entrance classes, but that formula is not required no more, because simply you find out the slope of the tangent by using derivative and the slope of the normal by this way, then you will get the equation of the tangent and normal, not necessary to remember this formula. So today is that much. I have given 5 to 6 questions there. You will solve all these questions and the next class will discuss, and again in the next class we will come to find out the equation of the tangent and normal under certain conditions, which will carry the 4 marks in your board examination. So thank you students for your patience and listening carefully. Thank you very much.